LangGraph's interrupt mechanism enables dynamic execution pauses by suspending graph processing and persisting state until external input is provided. This pattern facilitates human-in-the-loop workflows where validation, approval, or data entry is required before proceeding. The upcoming code demonstrates a problematic implementation where a non-serializable function is passed to the interrupt call, violating the requirement that interrupt payloads must be JSON-serializable. This will cause the graph execution to fail when attempting to persist the state, as the function object cannot be properly serialized by the checkpointer.
Def validate input value. Return len value 0. Def node state. Hash bad, passing a function to interrupt. Hash the function cannot be serialized. Response equals interrupt. Question, what's your name? Validator, validate input hash, this will fail. Return name, response.
This code demonstrates a critical limitation when working with interrupt in LangGraph, the requirement for JSON-serializable payloads. The example shows a node attempting to pass a function, validate input, as part of the interrupt payload, which will fail because functions cannot be serialized. The interrupt function is designed to pause graph execution and return a value to the caller, but this value must be JSON-serializable to work with LangGraph's persistence layer. When the graph state is saved during an interrupt, all payload data must be convertible to JSON format. Functions, class instances, and other complex objects violate this requirement and will cause serialization errors. This constraint exists because LangGraph needs to persist the interrupt state across process boundaries and potentially across different runtime environments. The checkpointer system requires all data to be serializable to ensure reliable state recovery when execution resumes. For production systems, this means interrupt payloads should be limited to primitive types, dictionaries with simple values, or other JSON-compatible structures. Let's break it down.
Def validate input value.
Defines a function named validate input that accepts a single parameter value. The function is declared, but its implementation isn't shown in this segment.
Return len value 0.
Returns a Boolean indicating whether the length of value is greater than 0, effectively checking if value is non-empty.
Def node state.
Defines a function named node that takes a single parameter, state, with type annotation state. The function signature indicates it expects a state object as input, but doesn't show any implementation or return value in this segment.
Response equals interrupt.
Calls the interrupt function with an empty dictionary as its argument, assigning the return value to the variable response. The function appears to handle some form of interruption or signal processing, though the specific behavior depends on the implementation of interrupt and how it processes the empty dictionary input.
Question, what's your name?
Defines a string variable named question with the value, what's your name? This creates a simple text prompt that could be used for user interaction or as input to a conversational system.
Validator, validate input hash, this will fail.
Assigns the validate input function as the validator for this configuration. The comment indicates this assignment will cause a failure, suggesting either validate input is not properly defined or doesn't meet the expected validator interface requirements.
Return name, response.
Returns a dictionary with a single key, name, mapped to the value of the response variable. The interrupt mechanism in LangGraph enables dynamic execution pauses for human-in-the-loop workflows, but it imposes a critical constraint. All interrupt payloads must be JSON-serializable. This requirement stems from LangGraph's need to persist state across process boundaries using its checkpointer system. The example demonstrates this constraint by attempting to pass a function, validate input, as part of the interrupt payload, which fails because functions cannot be serialized to JSON. The validate input function itself is straightforward. It checks if a value is non-empty, but its inclusion in the interrupt payload violates the serialization requirement. The node function attempts to use interrupt to pause execution and prompt for user input, but the inclusion of the validator function in the payload causes the failure. This highlights a key design trade-off. While interrupt payloads can include simple data structures like strings and dictionaries, they cannot include complex objects like functions or class instances. For production systems, this means validation logic must be handled separately, ensuring that only JSON-compatible data is passed to interrupt. The connective insight here is that LangGraph's interrupt mechanism prioritizes reliability and portability through serialization, which inherently limits the types of data that can be included in interrupt payloads.
The validator hunts for invisible strings, measuring nothing while demanding everything.